Good morning to everyone. I'm Jyoti. I'm basically a student. I'm an offline student at Allahabad and an off-campus student at BS program. Today I'll be presenting on building an adaptive AI training system, the parent algorithm of which I have chosen to be deep reinforcement algorithms and its alternatives. It's not only it's the one parent algorithm that has been coupled with classical machine learning predictive algorithms as well as LLMs and transformers in order to synthesize the present sentiment analysis for any particular stock use available in the market. We go to the next slide. The introduction. Artificial intelligence for predicting the upcoming value or trading algorithms. It's not any revolutionary change, it's just an evolutionary step, because trading and financial algorithms have been in the place since 1970s and 80s, and there have been multiple quantitative trading firms that deploy these algorithms in order to get optimum results at the cost of the minimum risk and emerging results. And if this graph we can see the rapid increase in the ratio of machine learning related finance papers has seen a sharp increase after 2015, clearly showing an AI can have clearly showing the power that is yet to be harnessed using AI just to predict the future value of particular stocks. Also, if I were to speak of reinforcement learning in specific, there have been emerging models, the stable-based like 3, the Google DeepMind, who have shown particular results that have been really accustomed, really specific about how we can predict the upcoming market. This calls for the research gap, as in why reinforcement learning in specific? Why did I not choose other supervised learning techniques or other present algorithmic techniques like, let's say, the mean trading strategy or peer reversal strategy? Why did I not choose them and go for DRL strategy? That calls for the research gap. Sure. Yeah. This on my right, this is just the simple moving average, the SME of 5-day, 15-day, 25-day of Apple and its closing prices. Over here, we can clearly see this, the closing price. This has seen a sharp volatile state. It actually goes off all the way from 189 and comes all the way over here to 181. For this, classical semi-supervised or classical supervised learning techniques face a shortage of data, and the other trading algorithms face a shortage of adaptive learning technologies. And for here, we propose to build open pipelines that leverage the power of deep reinforcement learning. That is, an agent that plays in the entire environment, learns on its own, develops a reward methodology, a policy of its own, and then learns how to simulate the entire stock market and then proceeds. It also, the main USP of our entire research work has been in developing proper pipelines that allow to integrate and merge public data streams and media parameters into our parent algorithms. As in, we might have clearly known how any particular stock value, be it in the NSE, in the NYSE, can be very much affected by the sentiments of the news available in the market that may come from any financial sources, Twitter, Instagram, Snapchat, Instagram or Facebook or anywhere. These have a direct impact on the stock value. Investors need to have a clear idea of which news they need to harness and which news needs to be processed to the DRL model, such that we can have a good idea while presenting it. Next slide, please. The methodology. This has been the entire model architecture that we propose. This side is completely the user interface, the investor interface that the user sees. It begins with having a wish list where the user selects a particular stocks that he wants the model to trade on, or we have also proposed a value proposition wherein the model itself chooses through an LSTM network about which stock is the most volatile and which stock has the most higher P by E ratio and the most surprise ratio. It is more viable to invest in that particular stock. After it completely goes to the database, and for this database, as of now, we have integrated the historical financial market data from the Yahoo Finance API key, as well as coupled with live market data from the high, low, close, and volume. These 5 parameters are taken, and once that data is pre-processed, we add a couple of more technical indicators. These technical indicators include RSI, MACD, Bollinger Band, the turbulence index, the particular risk aversion strategy that a particular stock contains. It includes all of those, and then this entire system, this entire data is parsed into this model. Over here, the LSTM acts as a predictor model that using dynamic time warping, it compares two such probable strategies in two different time frames and chooses which one has a higher probabilistic metric. As we would see earlier, that's called the Sortino ratio. The higher probabilistic metric of having a higher returns. It goes to the LSTM, which acts as a predictor, which is then fed to the DRL output. The DRL, we have deployed here an ensemble trading algorithm. Couple of DRL algorithms that have been fine-tuned to the best validation and rebalance window of 63. After quite a fine-tuning and optimization algorithms, we came to this number wherein DRL gives the best output after this through its ensemble algorithms. Now these ensemble algorithms include both value-based as well as policy-based. It goes to the selecting best output, and over here the LSTM fine-tuning comes into place. After this fine-tuning is completed, the DRL gives the output is screened by parameters. Now this part comes to major role. The evaluation based on the parameters. What parameters are these? Essentially these are the backtesting parameters, be it the Sharpe ratio, Kalman ratio, the omega ratio, Sortino, and the others as well. I'll be explaining those in the next part. Once if it's passing, then the particular trading strategy is executed in the live market simulation. In just the next slide, we will be seeing how this entire market simulation works. It goes over here, if it's yes, then it goes to updating the charts and the profit, the real-time wallet. The real-time wallet is reflected on the investor interface, and this entire thing goes. Yeah. If you can really see, the behind of the screen is actually a Python window that we have deployed. And over this, the background of the screen, whatever is working on, this portion, these are the buying signals, the green ones. And these these are the selling signals, the green ones. And here are the buying signals. This is the window of the model trading. And this portion, the highlighted window, is actually the sliding window of how much the model is taking into account. This model is just an GUI interface to envision all of this research that we have completed over here. What we see in the model architecture is prioritizing models based on superior evaluation metrics, maintaining a leaderboard as to which permutation and combination works the best, whether it is LSTM combined with TTW and DRL, or it's only DRL, or it's LSTM, DRL as well as LLMs in order to synthesize the particular market data that's available in the market, or using transformers to encode the textual data into numbers and features data, then passing it all the way over to DRL algorithm and bringing it all here. This is the second update. It goes all the way for training over here, and just in the second part, when I again open the Python window, I actually show in a window that I'm commenting out the training section and then again uncommenting the evaluation section. Just after I guess 20 seconds or something, once the model is just a little bit trained, in order to check its parameters, we can again go for it. Over here, why did we check large language models for automating problem solving, for automating the new synthesis part? Because transformers and LLMs have proved themselves to be one of the most accurate at understanding the financial news. For example, let's say Adani buys a 100-acre power plant in somewhere near Mumbai, the offshore Mumbai, or in Gujarat. This news can be categorized into three metrics: positive, negative, and neutral for an Adani stock. If our LLM categorizes it positive, it is likely to give it an index that it is 0.913 positive, and that index is then passed with the DRL to understand by what index will difference will the stock boomer of Adani or any other stock is this window exactly. This window is this part. I have just uncommented. I just commented out the trading V1, and now I uncommented the trading environment. If you can see over here, this one, the environment ID is backtesting V1. The observation data length is 1096 and step length is 40. That is, the sliding window length will be 40 and the entire observation window will be 1096. Over here, yes, Over here, what we can see is the window moves pretty much fast. That is not to deploy, that is not to signify that we are deploying intraday trade. No intraday trades have been executed. It's just because the timeline is very high, it's very large. Only because of that reason, it appears that these signals are being executed at a higher rate, but it's actually not the same. So this is over here. These graphs. This one actually shows the net, the returns made. This actually shows the drawdown. This graph. This shows the drawdown, and this one shows how the omega ratio graph, the maximum drawdown speeds. And this one shows the maximum peak that can be achieved. And this is actually showing the positive returns that are being made. Once this is done, we move to the next one. Yes. Results and model optimization. This was what you saw on the screen, the results for the same. DJI is the standard Dow Jones Industrial Index average for the NYSE, the New York Stock Exchange market. And this, when it was deployed from 2022 to 2024, 504 trading days, we had taken a series of 5 stocks: AXP, Apple, Amazon, Microsoft, and Google. And a portfolio made of these 5 stocks gave the output from here. The blue one signifies our model that had a net of $418,653 at the end of 504 days, while DJI just had $23,102 at the end of the entire period. The line graph shows how the model performed with these 5 stocks in only our portfolio. And the starting, this one was $1 million, and this one was where we ended, this was one where DJI ended. But the basic question that comes up, that when we are giving such high returns, we must also be taking that amount of risk. What is the risk aversion strategy included? The proper reward to risk ratio. That is seen in the this section. The annual volatility, Sharpe, Calmer, stability, maximum drawdown, omega, and daily value risk. Sharpe ratio generally provides the risk adjusted returns. Calmer ratio, this one provides the risk adjusted returns divided by the total drawdown, the maximum rock bottom that it hits. Stability, how stable is our trading strategies? Can it be tested across various multiple platforms? Maximum drawdown, maximum risk, omega ratio, Sortino ratio, and daily value risk. These are again parameters that show how stable it is and the maximum risk, the reward to risk ratio. Like for if I'm taking 100 rupees of risk, how much is the maximum reward that I can make if my risk taking ability is just these two? The next one. We just come to the conclusion, and these are the backtesting results. The ones, the exact parameters that I explained to you, these are the exact numerical results for the same when our model runs it. And future research is typically very high in this. Like if I were to give a quote myself, the AI trading industry is valued at a 10.31 billion market with a cumulative annual growth rate of 9.37%. So that practically gives our total serviceable obtainable market to almost. Yes, sir. Just the last, including the increasing the risk reward is our entire motive of artificial.
So we can have a quick 1 or 2 questions. Any questions?
How much your model parameters?
So, my model parameters. So there have been 2 sections of my model. The LLM we have used framework that's trained over 50 million parameters. It's over in the Hugging Face website. And our model is trained over around 128 MB of just historical market data. All of which it ranges all the way from 2009 to 2021 of just training data, and 2021 to present of testing and trading evaluation data. So that comes out to be 128 MB of all the stocks that we choose in our portfolio.
So you started from scratch, or you just pre-trained model?
No, sir. For the LLM, we have used a pre-trained model called framework, and then we have tuned the parameters with respect to whichever market we are using. Like framework is for the global market, so we tuned it for NSE, especially when we were using, or the NYSE or the forex exchange market. However, for the entire like the stock reading approach and the historical financial metrics approach, we build it all from scratch.
So the theme of this event is Atmanirbhar Bharat.
Sure.
So have you done it on BSE and NSE?
Absolutely, sir.
Okay. So where are the results?
So for BSE and NSE, I haven't placed it over here. For BSE, we chose a portfolio of 5 stocks again: Adani, Tata Power, Suzlon Energy, and Tata Reliance Power, and a fifth stock also as well. Even for that, we chose a portfolio, an initial starting value of 10 lakh rupees, and even for that, it went all the way up to we compared two indexes again, the standard index that was there for Nifty, and compared that with our strategy. Our strategy was at a more less about 8.68%, which was almost.
Okay, we do not have time, but I think it would have been interesting if you had shown those results. Okay, thank you.
Just if I could define.
We can discuss.